Hello, how are you doing? Week two. How it's a magical time. I'm sure you started to feel the difference already. Okay, so your weight has probably dropped a little bit, and you're probably feeling a little bit different. And so some people feel a little bit better and some people feel a little bit worse. However, it's part of the process. So today I'm taking you through a little bit about why the gut is so important. And it's actually a powerhouse. If our gut's functioning well, we feel good. And so this is where it's an important component to actually learn a little bit about it. Now, I'm going to be focusing a little bit on hormones. And you can say, what on earth has that got to do with the gut? Well, quite a lot, as you'll see. And so this is where I just really want to share with you that actually our gut is so, so important. And so digestion is vital for every aspect of our health and well-being. You will see in the presentation that our digestion is like the rest of the body. It is a heaving mass of hormones that are vital for our health and well-being. In fact, if we didn't have just a few of these, we probably wouldn't be here. So our focus today is on the hormonal aspect because it fascinates me, and I hope it's going to fascinate you, because if we don't have hormones, and this isn't just females, by the way, if we don't have hormones, we don't exist. And if they're not functioning properly, then we tend to feel terrible. And within our guts, the same as the rest of our body. So there are five main hormones that aid in the regulation of the digestive system in hormones. There are variations across the vertebrates, such as birds. So our arrangements are so complex and additional details are regularly discovered. So this is the ones that we know about right here, right now. And for instance, there are more connection to metabolic control, largely from the glucose insulin system, have been uncovered in recent years. And so we're learning all the time. And about like every other part of the body, we think we know it all. No, we don't. So gastrin, it's in the stomach, and it stimulates the gastric glands to secrete pepsinogen, an inactive form of the enzyme pepsin, and hydrochloric acid. The secretion of gastrin is stimulated by food arriving in the stomach, and the secretion is inhibited by low pH. So when we chew our food, it starts the whole process going. If we don't chew our food, then everything starts being inhibited, which is why I never, ever, ever recommend having things like smoothies and things, because we tend to chuck a load of food in and we're not chewing it. So we're not actually getting the benefits of it. So you have all this delicious stuff, all this amazingly nutritious things in it, but we won't be absorbing it. So then we have another hormone called secretin. It's in the duodenum, top part of the small intestine. And this signals the secretion of sodium bicarbonate in the pancreas, and it stimulates the secretion of bile in the liver. This hormone responds to the acidity of what's called the chyme. And the chyme is basically what they call the mixed up stuff that's been churning around in your stomach, and it comes out of the stomach and then it comes into the duodenum. Now, this one's an interesting one. Cholecystokinin, CCK, is so much easier. It's in the duodenum and stimulates the release of digestive enzymes, again in the pancreas, and stimulates the emptying of the bile in the gallbladder. This hormone is secreted in response to the fat in the chyme. So if you have a large amount of a food which has got a lot of fat in it, this is where the gallbladder comes to play, because the liver creates bile, and the gallbladder is your storage unit of bile. And so when we have a food which has a lot of fat in, so say, for example, you might have a pork belly or something like that, then the gallbladder is stimulated by this hormonal action to fire into the duodenum so that your body can process the food. So if you've had your gallbladder removed, then you can still digest fat. It's just you can't have that big spurt of fat which comes with certain foods. And so this is where it's quite interesting. So there's another hormone called gastric inhibitory peptide, GIP. Again, is in the duodenum and decreases stomach churning in order to slow the emptying of the stomach. Now, why is this so important? Because if you basically stop the churning of the gut, then food gets released slowly, and therefore you're more likely to absorb all the nutrients that are in that food. And so it's a really fine tuning, and it's really quite interesting. And I hope you find it interesting anyway. I just find it fascinating. And then there's motilin. It again is in the duodenum. I mean, you can see how the health of your duodenum is so important, and increases the migrating microelectric complex component of the gastrointestinal motility and stimulates the production of pepsin. So again, it's actually slowing down everything so that we can actually absorb as much of the nutrition as possible from our food, from the stomach. So the stomach's very acidic. We need it to be really acidic so they can break down all the components, and then it comes through from the stomach. There's also bicarbs that's been fed at the lower part of the stomach, so that when it comes through, it doesn't burn a hole in the duodenum. The acid in our stomach is incredibly powerful. And so when you have an acid stomach, very often, by the way, it could be that you haven't got enough stomach acid, and so everything can't be utilized. So we have a backup. And that's where some of the acid can be pushed through the sphincters that stop the backup. So that's where you can feel heartburn and stuff like that. Very often, heartburn can be helped with having a teaspoon of apple cider vinegar in warm water with a pinch of cayenne pepper. That can actually take away most people's heartburn. If you're still struggling with anything like that, then get hold of me. I have other tips and things that you can actually do. So now we've got appetite regulating hormones, and these are secreted by tissues and organs in the body, and they are transported through the bloodstream to the satiety center, a region of the brain that triggers impulses that gives us feelings of hunger or aids in suppressing our appetite. Now, ghrelin, I'm not sure if that's how you pronounce it, is a hormone that is released by the stomach and targets the pituitary gland, signaling to the body that it needs to eat. Now, PYY is a hormone that is released by the small intestine to counter ghrelin, and it is released by the hypothalamus and signals that you have just eaten and helps suppress our appetite. Now, this is if we are in alignment, if our body is in homeostasis, as I talked to you about last time. So the pancreas releases the hormone insulin, and that targets the hypothalamus and also aids in the suppressing of our appetite after we have just eaten. And there is a rise of blood glucose levels. As you can see here, if our insulin production is out of balance in any way, the hypothalamus will not send out signals to stop eating. And this in turn will affect the next hormone, and that is leptin. The last hormone is leptin, which also helps to suppress appetites. Now, leptin is produced by the adipose, our unwanted fat cells, and targets the hypothalamus. So basically, our fat cells produce leptin when they're full, and that messenger goes to the hypothalamus, and the hypothalamus gets the message and basically our appetite turns off, so we won't overeat. Now, this is the cycle we're really working on with this program. And as you will see, leptin is very complex. So leptin has quite a little job to do. And this slide shows the complexity of it all. And so it came about because we need it to obviously stop us overeating, but it's actually the indicator of energy disbalance. So when we're sort of it's very hard to sort of explain this, but basically we are adapted to fasting and flourishing. And so during the warm summer months, Mother Nature provides us with an abundance of fruit. And you might wonder why. Well, the reason fruit is there is not just for us, of course, it's for other animals. At that time of year, it's to actually help us go through the winter months where there used to be scarcity. So where we used to have scarcity. And so consequently, the reason that leptin is so interesting is it's adapted so that it actually this is where we get leptin resistance. And so fructose can really affect that. So what I mean by that is if you have an overeating of fruit, fructose in particular, is basically leptin will then think that we're going into fasting mode, where we need to fill our fat cells up to the most capacity that it can be. And so basically then we accumulate fat. Now this would have seen us through the winter months and we'd have become lean again, and then we'd have survived. We'd have survived the winter. But now, because everything's available all year round, we are in leptin resistance at all times. So this is what we really need to know. If you want to go deeper, then you can have a look at this slide and dive deeper into the rationale behind leptin and how it works with all of the other conditions and organs of the body and glands. And so it's really quite fascinating. So a little bit more on fructose. Fructose induces insulin resistance, which induces leptin resistance. So the reason for this is because of starvation, prevention of starvation. So fructose only available 1 to 2 months of the year, followed by 4 to 5 months of winter with no food available or very little. If leptin worked all the time, you couldn't store the energy. So that's why naturally leptin came along, but when fructose was introduced. So does this make sense? Because if you have fruit all the time, you are going to be in leptin resistance. And so consequently, we're in leptin resistance. We cannot utilize that fat as energy. And so now it's consumed in huge amounts. Think fruit juice, breakfast cereal, we're actually recommended that we have so many pieces of fruit a day. That could be the root cause of us putting on weight in the first place. So it's just mind-blowing, really, when you really think about it. It could be fruit, wonderful, healthy, vibrant food could be the root of our obesity epidemic because of the availability. Okay, so enough about fructose and leptin. Let's jump in to insulin. Insulin is vital for many actions within our body. Insulin, like any other hormone, is linked to digestion and the gut. And as you can see, it's vital for our appetite regulation too, and so much more. Here's a little bit of information. Insulin is a hormone made by the pancreas. I'm sure you know that. And it allows the body to use sugar, glucose, from carbohydrates in the food that you eat for energy to store glucose for future use. Insulin helps keep your blood sugar level from getting too high, hyperglycemia, or too low, hypoglycemia. The cells in your body need sugar for energy. However, sugar cannot go into your cells directly. After you eat food and your blood sugar level rises, in your cells in your pancreas, known as the beta cells, are signaled to release insulin into your bloodstream. Insulin then attaches to and signals cells to absorb sugar from the bloodstream. Insulin is often described as a key, which unlocks the cell to allow sugar to enter the cell and used for energy. After you eat, cells in your pancreas are signaled to release insulin into the bloodstream. If you have more sugar in your body than it needs, insulin will help store the sugar into your liver and releases it when your blood sugar level is low or when you need more sugar, such as in between meals or during physical activity. Therefore, insulin helps balance out blood sugar levels and keeps them in a normal range. As blood sugar levels rises, the pancreas secretes more insulin. Now, if we secrete too much insulin, then what does it do? It stores that sugar away as fat, and then we become insulin resistant. And so basically, if you think about it, it's really, really, really important. Now, I couldn't talk about insulin without harping on about magnesium. And as you know, or you probably know by now, that magnesium is, I believe, is a key to us having good health. If you don't have enough magnesium, you will not have good insulin levels. You cannot, because you cannot make perfect insulin, which is why I get you to do transdermal. By doing it transdermal, it bypasses the bloodstream and then it can go to where it's needed as a building block to your hormones and also your digestive enzymes. So please, please, please use the magnesium. Use it, use it, use it. It just works. It is pure magic. And I don't know if you know my story, is very short, briefly, is when I studied nutrition in the late 80s, I realized that I was magnesium deficient. And I tried the tablets that were available at the time and didn't feel any different. And then as the years went by, new products kept coming out and I tried them and they didn't work for me that well and they didn't work for many of my clients at the time. And so consequently, in 2006, when I went back to the UK and met a colleague of mine, and she said, Karen, have you tried this? And it was transdermal magnesium. And literally, I noticed the difference straight away. I came back to the UK, back to New Zealand from the UK, and I hunted everywhere for transdermal. I couldn't find it. So we started to import the magnesium from the Dead Sea, which I found was the best one for me, and started to create magnesium transdermal, and it has evolved since then. And so consequently, I know that this works. I have tried other magnesium since, but I found the transdermal works best. Now, put it anywhere in your body, just don't get it anywhere near your eyes. So I recommend not putting it on your face, and because it stings. And having done that many, many times when I've been making it. So, okay. The second brain in your gut. Now, this is an important component. The gut has a mind of its own, and it's called the enteric nervous system. Just like the larger brain in our head, researchers say the system sends and receives impulses, records experiences, and responds to emotions. Its nerve cells are bathed and influences by the same neurotransmitters. The gut can upset the brain, just the brain can upset the gut. The gut's brain, or enteric nervous system, is located in the sheath of tissue lining the esophagus, stomach, small intestine, and large intestine. It is considered a single entity. It is a network of neurons, neurotransmitters, proteins that zap messages between the neurons, support cells like those around the brain proper, and a complex circuitry that enables it to act independently, learn, remember, and as the saying goes, produce gut feelings. Just remember this, because your gut is actually influencing your brain and your brain's influencing the gut. The gut's brain is reported to play a major role in human happiness and misery. Major gastrointestinal disorders like colitis, irritable bowel syndrome, originate from problems within the gut's brain. Also, it is now known that most ulcers are caused by bacteria, not by hidden anger as one's mother. However, the underlying root might be the anger sitting in the stomach, which could be why the bacteria was allowed to fester there. And it's just a thought as I was thinking, as I was creating this slide, is what came first? Was it anger that was eating away and therefore the bacteria could come in and proliferate? Or was it the bacteria coming in, proliferating, causing anger, etc., etc.? So what comes first, chicken or the egg? And so this is what I find fascinating about our human body. Details of how the enteric nervous system mirrors the central nervous system has been emerging in recent years. According to Michael Gershon, a professor of anatomy and cell biology at Columbia Presbyterian Medical Center of New York, that's a mouthful. He's one of the founders of a new field of medicine called neurogastroenterology. The gut contains 100 million neurons, more than the spinal cord. Major neurotransmitters like serotonin, dopamine, glutamate, norepinephrine, nitric acid are in the gut. Also, 24 small brain proteins called neuropeptides are there along with the major cells of the immune system. Encéphalins, a member of the endorphin families, are also in the gut. The gut is also a rich source of benzodiazepines, the family of psychoactive chemicals that includes ever-popular drugs such as Valium and Xanax. In evolutionary terms, it makes sense that the body has two brains, says Dr. David Wingate, a professor of gastrointestinal science in the University of London and consultant at the Royal London Hospital. The first nervous systems were in tubular animals that stuck to rocks and waited for food to pass by. According to Dr. Wingate, the limbic system is often referred to as the reptile brain. As life evolved, animals needed a more complex brain to finding food and sex, and so developed a central nervous system. But the gut's nervous system was too important to put aside inside the newborn head, with long connections going down to the body. Says Wingate, offsprings needed to eat and digest food at birth. Therefore, nature seemed to have preserved the enteric nervous system as an independent circuit inside higher animals. It is only loosely connected to the central nervous system and can mostly function alone, without instructions from up here. Now, I'm not sure that I believe in the evolutionary system, but it makes sense that we have an amazing, amazing system that connects each other. And when I think of the reptilian brain, I think of the diencephalon, which is where the hypothalamus and pineal and pituitary live. And I do believe that they are inextricably linked. And who rules the roost? Well, I think it depends on the individual. This indeed is a picture seen by developmental biologist. A clump of tissue called the neurocrest forms early in an embryogenesis. One section turns into the central nervous system. Another piece migrates to become the enteric nervous system. According to Dr. Gershon, it is only later that the two systems are connected via a cable called the vagus nerve. The brain sends signals to the gut by talking to a small number of command neurons, which in turn send signals to gut interneurons that carry messages up and down the pike. Both command neurons and interneurons are spread throughout the two layers of gut tissue, called the enteric plexus, and the submucosal plexus. Command neurons control the pattern of activity in the gut. The vagus nerve only alters the volume by changing its rate of firing. The plexuses, also known, contain glial cells that nourish neurons, mast cells involved in immune responses, and a blood-brain barrier that keeps harmful substances away from important neurons. They have sensors for sugar, protein, and acidity, and other chemical factors that might monitor the progress of digestions, determining how the gut mixes and propels its content. So that goes back to the other hormones. As light is shed on the circuitry between the two brains, researchers are beginning to understand why people act and feel the way they do. When central brain encounters a frightening situation, it releases stress hormones that prepares the body to fight or flee. The stomach contains many sensory nerves that are stimulated by this chemical surge, hence the butterflies. On the battlefield, the higher brain tells the gut brain to shut down. A frightened running animal does not stop to defecate, according to Dr. Gershon. Fear also causes the vagus nerve to turn up the volume on serotonin circuits in the gut. Thus, overstimulated, the gut goes into higher gear and diarrhea results. Similarly, people sometimes choke with emotion. When the nerves in the esophagus are highly stimulated, people have trouble swallowing. Even the so-called Malox moment of advertising can be explained by the interaction of the two brains, according to Dr. Jackie D. Wood, chairman of the Department of Physiology in Ohio State University. Stress signals from the head brain can alter nerve function between the stomach and esophagus, resulting in heartburn. In cases of extreme stress, Dr. Wood said the higher brain seems to protect the gut by sending signals to immunological mast cells in the plexus. The mast cells secrete histamine, prostaglandin, and other agents that help produce inflammation. This is protective. By inflaming the gut, the brain is priming the gut for surveillance. If the barrier breaks, then the gut is ready to do repairs. Unfortunately, the chemicals that get released or also cause diarrhea and cramping. There is also an interaction between the gut, brain, and drugs. According to Dr. Gershon, when you make a drug, you have to have psychic effects on the brain. It is very likely to have an effect on the gut when you don't think about it. He also believes that some drugs developed for the brain could also have uses in the gut. For example, the gut is loaded with the neurotransmitter serotonin. According to Gershon, when pressure receptors in the gut lining are stimulated, serotonin is released and starts the reflexive motion of peristalsis. A quarter of the people taking Prozac or similar antidepressants have gastrointestinal problems like nausea, diarrhea, and/or constipation. These drugs act on serotonin, preventing the uptake by target cells so that it remains more abundant in the central nervous system. I know this is quite a lot to take on board, but it's a really important component, because if we're taking something for headache or whatever, it's going to actually affect your digestion. And so consequently, have to make you think, do you actually need that drug, that herb, that fill in the blank? Because it does have interaction within the brain. So Gershon is also conducting a study of the side effects of Prozac on the gut. Prozac in small doses can treat chronic constipation. Prozac in large doses can cause constipation, where the colon actually freezes up. Moreover, because Prozac stimulates sensory nerves, it can also cause nausea. Some antibiotics like erythromycin act on gut receptors to produce oscillations. People experience cramps and nausea. Drugs like morphine and heroin attach to the gut's opiate receptors, producing constipation. Both brains can be addicted to opiates. Just makes you think, doesn't it? Victims of Alzheimer's and Parkinson's disease often suffer from constipation. The nerves in their gut are as sick as the nerves in their brains. Just as the central brain affects the gut's brain can talk back to the head. Most of the gut sensations that enter conscious awareness are negative beings like pain and bloatedness. The question has been raised, why does the human gut contain receptors for benzodiazepine, a drug that relieves anxiety? This suggests that the body produces its own internal source of the drug. According to Dr. Anthony Basil, a neurochemist in the Neuroscience Laboratory at the National Institute of Health at Bethesda, MD, an Italian scientist made a startling discovery. Patients with liver failure fall into a deep coma. The coma can be reversed in minutes by giving the patient a drug that blocks benzodiazepine. When the liver fails, substances usually broken down by the liver get into the brain. Some are bad, like ammonia and mercaptan, which are smelly compounds that skunks spray on you, said Dr. Basil, but a series of compounds are also identical to benzodiazepine. We don't know if they come from the gut itself, from bacteria in the gut, or from food, but when the liver fails, the gut's benzodiazepine goes straight to the brain, knocking the patient unconscious. Isn't that fascinating? I never really thought about it until I started researching this. So the payoff for exploring the gut and the head-brain interaction is enormous, according to Dr. Wood. Many people are allergic to certain foods, like shellfish. This is because mast cells in the gut mysteriously become sensitized to the antigens in the food. The next time the antigen shows up in the gut, the mast cells call up a program, releasing the chemical modulators that try to eliminate the threat. The allergic person gets diarrhea and cramps. Many autoimmune diseases like Crohn's disease, ulcerative colitis, may involve the gut's brain, according to Dr. Wood. The consequences can be horrible, as in Chagas disease, which is caused by a parasite found in South America. Those infected develop an autoimmune response to neurons in their gut. Their immune systems slowly destroy their own gut neurons. When enough neurons die, the intestines literally explode. A big question remains: can the gut's brain learn? Does it think for itself? Dr. Gershon tells a story about an old army sergeant, a male nurse in charge of a group of paraplegics with their lower spinal cords destroyed. The patients would get impacted. At 10 a.m. every morning, the patients got enemas. Then the sergeant was rotated off the ward. His replacement decided to give enemas only after compactions occurred. But at 10 o'clock the next morning, everyone in the ward had a bowel motion at the same time, without enemas. Had the sergeant trained those colons? The human gut has long been seen as a repository of good and bad feelings. Perhaps emotional state from the head's brain are mirrored in the gut's brain, where they are felt by those who pay attention to them. So, are you paying attention? So, what's your gut health like? Are you having a regular bowel movement, at least one per day? Are you feeling bloated after food? Are you suffering with food intolerance? Do you get regular headaches? Do you have trouble with losing weight? Are you or do you feel depressed or anxious at times? Your second brain reacting? Do you feel you need a bowel cleanse? Do you take a probiotic, not just fermented food? Now, bowel cleanse information. So I just wanted to go through a few things that can be troubling when you're on a program such as this. So when we go into using fat as energy, things change. Very often, our bowels will stop working. And the main reason for that is when we start functioning well, when the hypothalamus starts working, then we utilize water and everything differently. And so when we do that, then our colon very often will start reabsorbing more water, because that's what the colon does. The colon's job, large intestine's job, is to take the water out of what's the chyme, which is very watery, hence diarrhea. If you get diarrhea, then the colon hasn't been doing its work. So basically what happens is the colon with its peristalsis is squeezing the chyme so that it takes away the water. And so when we're utilizing fat as energy, then everything changes. And so basically we have to make sure that we're drinking enough water. So bowel cleanse instructions. So why is cleaning the bowel so important? I get asked about this all the time. And after all, we do have a automatic system, don't we? And so I just want to go through some suggestions. So if you are struggling with constipation, now this is for the original program, and so there's two sorts of instructions here. So if you're on the original, I recommend that you get a product by Nature's Sunshine called LBS2. So it's a lower bowel formula, and it's a laxative basically. And we used to be able to get a product called Alpine Tea, but it's been banned, but it might be available in other parts of the world, which is why I've left it here. Is use charcoal to help cleanse your bowels, but also use LBS2. So if you have constipation or you feel constipated, then it's a good idea to use 2 charcoal capsules at night, and that might be enough, because it could be that your body is unable to eliminate all of the gunk quickly enough. So that could be it. And also, I'm going to do another video around Himalayan salt sol. And basically, it's a saturated solution of Himalayan salts. So before you even try LBS2 as a laxative, do the Himalayan salt sol up to a tablespoon. So start with a teaspoon in warm water. Don't have it neat, it'll make you vomit. But basically in warm water, and have that whenever in the day. And you can work your way up to a tablespoon or more, because it's A, really good for electrolytes, and B, when most of us are deficient in salt. So if you do that very often, that'll keep your bowels going. And so if that doesn't work, then take the LBS2 and use it at night. So 2 capsules to start with, and then gradually, and I mean gradually, increase. So that's for the original. Now, if you are on carnivore, definitely do the Himalayan salt sol. Your body might take time to adjust. And for many people, when they go on carnivore and you're introducing more fat, what happens is you get loose bowels. And the reason for that is because we're not depending on fiber for our bowel work. And so what we have to do is re-educate the bowels. And very often with carnivore, you don't have so much waste products, so you don't go to the toilet as often. If you're not feeling bloated and backed up and everything, don't worry about it. I will go into this in a bit more detail when we're on our calls, but basically do not get concerned about it carnivores, because you might have the opposite effect. If you do have diarrhea for a long period of time, use charcoal, because charcoal will help slow, but also will help gather any toxins and everything that could be causing problems. So it's quite a complex subject, because when you're on the original, we're working with very different modalities or modes, really, that the body's in. So what I see with the carnivore is basically because the colon has got so used to having fiber, the colon doesn't have to do so much work. So consequently, it's got lazy. So we're re-educating our colons, and so that's why. So here's a schedule for a bowel cleanse if you choose to do it. So basically, it's this is for the original. So it's really quite interesting, bowel cleansing, because for those of you who don't know, I used to be a colonic irrigation therapist, and so consequently I know quite a bit about bowels. But what I do know now is that we don't really need it as long as we're having the right food. If we're having the right food for us, then we don't tend to need bowel cleansing, because the body will eliminate, and the body will do its job as long as we're giving it the right food and it's not causing inflammation. So very often having regular bowel motions, more than once or twice a day, could be that your bowel's being irritated. So totally different to the way I was trained, but I do know that it works. Okay, right. So that's it with the gut. There's so much more, of course, but I think we don't want to get you bored too much. Awesome. Bye for now.